Good morning, everyone.
Good morning, ma'am. Good
Okay,
morning,
so
ma'am.
as we discussed, we are going to start our second unit, correct? Yes, any doubt about the first unit? We have completed our whole first chapter. What we have seen in that, first we have seen the Lagrange's equation of motion. Uh, okay, let us start with the first one. We have seen some of the basic definitions, and then we've gone for the total energy is conserved T plus T1 plus V1 is equal to T2 plus V2 is equal to constant. These conservation theorems we have proved for a single particle as well as for a n number of particles, or rather we can say a system of n particles. After that we have seen Lagrange's equations of motion, correct, and some of the examples on that and some theorems, right? And before Lagrange's equation of motion, that means whenever you want to derive any Lagrange's equation of motion, you must know what are the generalized coordinates and degrees of freedom. Yes, any doubt about all these concepts, generalized coordinate, degrees of freedom, their types, and then Lagrange's equation of motion, the cases which we have discussed for the Lagrange's equation of motion. What are the cases? Okay, let it be. Now let us go for the next point, next unit, that is variational principle. Okay, in the variational principle, we are going to see how to find out the maxima and minima of a given function. Right. Now, before that, we must uh, see about what is a weightage for this in a SETNET exam. So, those who want to really give a SETNET exam, for SET and as well as NET exam, this second chapter is very important. Okay, from whole classical mechanics paper, only the weightage is given for the second unit, that is a variational principle. In SETNET exam, many questions are asked on the variational principle, that is second unit only. Okay, so those who want to prepare for this exams, they can prepare your second unit. Okay, now in that, firstly we will go for the definition of functional, because here we are going to deal with the maxima and minima of those functions. By a function means that the quantity whose values are determined by one or several functions. Domain of the functional is a set of suitable functions. Okay, functionals means what? By means of functional means a quantity whose values are determined by whose values are determined by whose values are determined by one or more functions by one or more functions, that is, we can say the domain of functional is set of suitable functions. Okay, so what is a domain of functional? It is set of all a set of suitable functions. The word suitable is important here. That means now calculus variation, it has its origin in the generalization of elementary theory of a maxima and minima of a single or more than one variable. Its objective is to find out the stationary values of the function. क्योंकि हम यहाँ पे variational principle में क्या study करने वाले हैं? Simply we are going to find out the maxima minima of the function, right? So to find out maxima and minima, we must know what are the rules to find out the maxima and minima. right? By first we are going to equate f dash equal to 0, then we find f double dash whether it is greater than 0 or it is less than 0. Depending on that, we say either it is maxima or minima. I have given this as a homework for you. I don't know how many of you do this. So actually f dash means what? Slope of a tangent at a point, which I have told you in detail how it works, those who were present actually for the lecture. So f double dash means what? It is going to tell you the rate of change of a slope of a tangent. Okay. F dash is slope of a tangent and f double dash is nothing but rate of change of a slope of a tangent. That means by how much rate the slope of a tangent, rate of change of a slope of tangent. By how much rate the slope of a tangent is changing, that will be described by f double dash. And hence, we say that f double dash is greater than 0, then it is minima. And if f double dash is less than 0, then it has a maxima. The complete figure can be described by this one function. Suppose the function is like this. Here you have f dash is 0. Okay, f dash is 0. Why f dash is 0? Because slope of a tangent is 0, no? How to find out this? That is difference in y coordinate. What will be difference in y coordinate? Y coordinate हे fix होणार ना? Yes or no? Hello.
Yes, ma'am.
काय येणार आहे y ची व्हॅल्यू? Y is 0. Difference in y coordinate. Because we have only constant, no? Y is equal to some number, it is there. So this line, what is the difference between y coordinate? एक ही coordinate है यहाँ पे, right? y1 minus y2, because y1 and y2 both are same, divided by x1 minus x2, whatever may be the denominator, and numerator is 0, it means that your f dash is 0, right? Now here you can see, now you can find out the slope of tangent here as well as here. This figure completely describes you about what is maxima, what is minima, what is a concave, what is concave down, what is a convex function, right? And then you can able to see that what is f double dash, uh, whether it is greater than 0, less than 0, right? And if suppose your function is increasing, suppose your function is increasing, so what is the effect on f dash? Increasing function माहिती आहे का? You are not buying increasing and decreasing function also. Quite dangerous. So what do you mean by increasing function? Suppose I draw a graph like this. And suppose here I have a point x1. Suppose I have a point x2 here. And this is what f of x1 and this is what your f of x2. Correct? So here I can have x1 is less than x2. आहे का नहीं?
आहे.
Yes, ma'am.
हाँ. Why x1 is less than x2? रियल लाइन पे है ना ये, रियल लाइन पे लेफ्ट साइड के वैल्यूज क्या होते हैं, राइट साइड के वैल्यूज पे क्या इफेक्ट होता है. You should know this concept. F of x1 and f of x2. Now here value of f of x1 is here and value of f of x2 is here. So obviously you can see f of x1 is less than f of x2. Correct? And if this happens, then we say that the function is increasing. And if it happens reverse, then we say that the function is decreasing. Okay. So here you should go for the thing that what is the nature of function here and what is the nature of function here. Then you have to find out whether it is increasing or decreasing function. Then you have to find out what is concave up, what is concave down, right? and then slope of a tangent. Okay, how to find out the rate of change of a slope of tangent? Suppose I have considered the same example. Okay, at the same point we can have a different that is rate of change of a slope of tangent. I am going to find out. Okay, and this will work as a f double dash, and it will describe you whether your function is maximum or minimum. Okay, so in this chapter we are going to study calculus of variation. The first concept of calculus was described by your equation f is equals to ma itself, because here we have used the concept of a derivative for the acceleration, right? The concept of calculus we have studied origin in the generalization of elementary theory of maxima and minima of a single or more than independent variable. And for that one, now here in this unit we are going to study the some functionals, and we are going to find out maximum and minima of those functionals. Okay, now let us take one example of a functional. An example of a functional I can consider to be the length between the 2 points. I can consider this to be length between the 2 points x naught y naught and x1 y1 along the curve y is equal to y of x, or we can say along the curve y of x. Okay, so we have to consider functional. That is, functional means what? It is nothing but a, with the help of set of functions we have defined. We can say functional is with the domain of function is nothing but the set of suitable function. Okay, functional means what? A quantity whose values are determined by one or more function. Okay, you will come to know how functional is defined by this example. Now we know that the length between the 2 points can be find out with the help of a distance formula. See, अगर आपको response नहीं देना है तो it's okay. I will directly put a recorded lecture of last year. लाइव लेक्चर लेने का मीनिंग ही क्या है ना, कि आप भी रिस्पॉन्स कुछ देना चाहिए. सभी लोग ऐसे ही आराम से बैठे हुए रहते हो. No response, no homework questions. Never you go through the homework question. I don't think so. You. Otherwise, already the recorded lectures are available on the YouTube. You can see those lectures if you don't want to give any response. Okay, let us go for the solution. Take a point P and Q. That is, let us take a point P with the coordinates say x1, y1, and suppose point Q is with the coordinates say x0 and y0. Be any 2 points, and now we have to find out the distance between the 2 points P and Q. Now directly, instead of finding a distance directly, because if suppose the point P is in Solapur and point Q is in the Pune, so directly you cannot go for measuring the distance with the scale. Okay, what you have to do, you have to find out the integration, right, for the given set of values. क्या करना है आपको? Let us assume that we have the point P is here with the coordinates say x1, y1, and suppose Q is with the coordinates say x0, y0. So, to find out the distance between the 2 points P and Q, let us consider the two neighboring points, say xy, and here x plus dx, y plus dy. Okay, we have considered the two neighboring points. Now distance between the two neighboring point, I can denote it by ds. Then by distance formula, what is the distance between the two neighboring points? First we will find out the distance between very small neighborhood points, and then we will generalize the concept. We will take the integration from point P to Q. ds is equals to under root dx square plus dy square. So hence we can have ds square is equals to dx square plus dy square. Now the total length between the 2 points P and Q can be found with the help of a integration formula. Now we have found the distance between the two neighboring point. Very small distance is there in between these 2 points, which we can find out with the help of a distance formula. Now to find out the whole length, I can denote the whole length by L is equals to integration P to Q ds. So integration of this ds from point P to Q. This will be described by the total length of a path from point P to Q or Q to P, which is equal to, I can write this as P to Q, ds is nothing but under root of dx square plus dy square. Okay. Now to find out the value of this integration, what I can do, I can take dx common. Okay, if I take a dx outside, what I remains inside this, I will remain with dy by dx bracket square and here dx outside. So we have integration p to q under root of 1 plus y dash. Okay, dy by dx is y dash and it's a square as it is and dx is outside. So we can now see that the length is also one functional. Okay. So in this example, length is a functional and generally the length between the 2 points P and Q can be described with the formula integration P to Q under root of 1 plus y dash square dx. Now this can be written as the value of integration I is a length and it is length is a function of y because here it is written in terms of y 1 plus y dash square. It is given by integration P to Q. Now here as we are in a particular example, so that's why now we can write down the general concept that the value of a length can be or it can be any functional can be in between the with the help of three variable x, y and y dash dx. Okay. So what is the integration? Integration within the limit p to q can be an integration of a function with the three variable x, y and y dash. Here we are writing in general. Actually we found it is 1 plus y dash square. So in the y dash square also we have dy by dx. So y is involved, x is also involved and y dash is there. So we can say that length of the function is described with the help of a three variable x, y and y dash. So this is what the total length between the 2 points P and Q. Instead of writing like this, you can write down within the limit x1 to x2 because as we are going to integrate with respect to x, directly instead of putting P and Q, you can put up the values of x. Okay, that is limits of x will be described. This is nothing but your length of a function which is a function of y and this is what the value of integration from x1 to x2. And this is what extremum. Extremum means what? Either maxima or minimum. Now, there's in calculus of variation, we find the function y of x between the 2 points such that the total length must be having an extremum value. Okay, because our aim is to find out extremum value. Extremum means either maxima or minima. Now, in the case if you are discussing for the distance between the 2 points, you will find out the minimum one, correct? But minimum is always not possible, right? Because suppose you have a 2 points A and B, you can if there is a straight line joining between the 2 points, that is a shortest distance between the 2 points. But if suppose that shortest distance is not possible, suppose sometime it is not possible since between the 2 points A and B, suppose there is a river, suppose there is some obstacle, so you have to move from some another way, right? So here extremum means what? Either maxima or minima. So length is a functional which is described with the three variable x, y and y dash, and the integration of this function will give you the value of a length between the 2 points, and here it can be either maxima or minima. Okay, so now let us go for the next point, basic lemma in calculus of variation. And this lemma is very important. Many times we are going to use this lemma in our next theorems. basic lemma in the calculus of variation. So first I will write down the statement for this basic lemma of calculus of variation. If x1 and x2 are the points given such that if x1 and x2 are such that x1 is less than x2 are two fixed point constants and g of x is a particular function and g of x is a particular function given in the interval x1 to x2. G of x is a function given in the interval with the values of x lying in between x1 to x2, and if integration x1 to x2 g of x into eta of x dx is equals to 0 for any choice of a continuous differentiable function eta of x, and the condition for any choice of continuous differentiable function eta of x such that, what is the condition such that eta of x1 is equals to eta of x2 is equal to 0. Then g of x is equal to 0 identically in the interval, then the function g of x will be equal to 0 identically in the interval x1 to x2. Okay, that means g of x is completely equal to 0 in the interval x1 to x2. Now go through the whole statement. What is given in the statement? Given that x1 is less than x2, these are the two fixed point constant. Then g of x is a particular function. We have been provided with some particular function g of x, which is defined in the interval x1 to x2. And if the integration x1 to x2 g of x eta of x dx is equal to 0, and what is the consideration? G of x eta of x dx, that is integration of g of x and eta of x is equal to 0. G of x is a one particular function, and for any choice of continuous differentiable function eta of x. Okay, what is eta of x? It is given that it is continuous differentiable function on the condition eta of x1 is equal to eta of x2 is equals to 0. Then we say that g of x is equal to 0 identically in the interval x1 to x2. Okay, so startingly we have been provided that the 2 points x1 and x2 and g of x is a particular function. Next, the integration of those function g of x into eta of x is 0. And what is the condition on eta of x? Eta of x must be continuous differentiable function. Okay, and eta of x1 and eta of x2 equal to 0. Then means what? We have to prove. आपल्याला फक्त हेच प्रूव्ह करायचं आहे. Then we have to prove g of x is equal to 0 in this interval. Now let us start with the proof. So what is given that we have to write down first, and if our aim is to prove that g of x is equal to 0 identically, what do you mean by identically? It means that it is completely equal to 0. G of x is completely equal to 0. So if I want to prove g of x is equal to 0, let us prove the result with the help of a contradiction. Assume that g of x is not equal to 0 in the interval, right? Assume that g of x is non-zero, right? First we have to write down all the given thing. Already I have written, so that's why I am not writing in the proof. So what is our aim to prove? G of x is equal to 0. So let us assume that g of x is not equal to 0 at some point. Okay, identically equal to 0 मतलब क्या है, हमें प्रूव करना है कि g of x is completely 0 in a whole interval. Now let us assume that g of x is non-zero at some point x is equals to x dash. Let us assume that g of x is non-zero at some point x is equal to x dash. ओके, त्या इंटरवल मधला कुठलाही एक पॉइंट घ्या आणि त्या पॉइंटला तो g of x हे नॉन झिरो आहे असं अज्युम करायचं. ओके, so if we are assuming that g of x is non-zero and let us assume non-zero means what? Let us assume that g of x dash is greater than 0. Okay, let me name it as some equation 1. Non-zero means what? Either less than 0 or greater than 0. First we will go with the g of x dash is greater than 0. Okay, and then you can write similarly काय होणार आहे इथे g of x dash if it is less than 0 we have to again prove the result. Okay, first we'll go for the first one. Let us assume that at some point of your interval g of x dash is non-zero means what? Either it is less than 0 or greater than 0. So let us assume that it is greater than 0, right? And given that your function g of x is a particular function which is defined in the interval, so here let us assume that g of x is a continuous in the interval. G of x is a continuous function in the interval x1 to x2. It means that if g of x is a continuous function in whole interval, it means that g of x is continuous at a point x is equal to x dash. If it is continuous in a whole interval, it means that it is continuous at that point also, right? So there exists some small neighborhood. So there exists some small neighborhood around the point x dash, which I can consider say x1 dash and x2 dash. Okay, that means I can say x dash is a point which is belonging to some small neighborhood. Okay, now let me show you how it works. First, let us assume that I have a point some here I have x1 and x2. In between them I have considered this x dash, and what is the interval? Let us assume that this is what a neighborhood, this is x1 dash and this is what a x2 dash. Okay, considering x1 dash is less than x2 dash and x dash is lying in between these two, so x dash is in between the 2 point x1 dash and x2 dash. Okay, now we have assumed that g of x is greater than 0 in this interval. In which interval? x1 dash to x2 dash. G of x is greater than 0. Now let us see what is the effect on this equation. What is our equation given to us? In the statement we have been provided that this in this interval x1 to x2 g of x into eta of x dx is 0. Right? We have been given that. Now let us see what is the effect on the equation. Integration x1 to x2 g of x into eta of x dx is equal to 0. Right, now we have to now define what is eta of x. Right, for any choice of eta of x I can have eta of x is 0 and is equal to x1 minus x1 dash, it's a square, and x2 minus x2 dash, it's a square, and it is equal to 0 in the interval. In which interval? In x1 to x1 dash and in x1 dash to x2 dash we have defined one function, and in the next interval x2 dash to x2 the eta of x is a function which is 0. Okay, now you can see the intervals here. In the interval x1 to x1 dash eta of x is 0. In this interval also it is 0. Now we are only bothering about here. Okay, so in this interval we have to find out the result. Okay, so we have constructed our eta of x in such a way that we get the result. Okay, क्योंकि हमें already पता है कि eta of x is a one continuous function which has a consideration that eta of x1 and eta of x2 is equal to 0. हे दिलेला आहे ना, eta of x1 and eta of x2 are equal to 0. So that's why I have written here this is equal to 0 in this interval x1 to x1 dash and in the x2 to x2 dash. In this interval, your function eta of x is 0. Your function eta of x is 0 in the interval x2 dash to x2. So we have constructed our function in between these two, that is in the interval x1 dash to x2 dash, in such a way that we'll get the result. Okay. Now the above equation can be written in the 3 format, right? The interval x1 to x2 can be now divided into 3 integrations. So first you can say here the integration x1 to x2 g of x eta of x dx will be equal to, it is now x1 to x1 dash plus integration x1 dash to x2 dash plus next integration x2 dash to x2. Right, here we have this is 0, here is also 0, but here we have some value, correct? Now here you can write down this as integration within the limit x1 to x1 dash, it is g of x into eta of x dx plus integration x1 dash to x2 dash g of x into eta of x dx plus next is integration x2 dash to x2 g of x eta of x dx. Right, so here it is 0, here is also 0, so we remains with the second one. So integration x1 dash to x2 dash, now g of x as it is, what is the value of eta of x? We have assumed here the value of eta of x in this interval is x1 minus x1 dash square and x2 minus x2 dash, it's a square, dx is equals to 0. Why it is 0? Because already it is given, no? In we have been provided that the integration g of x and eta of x is equal to 0. वही equation हम लोग solve कर रहे हैं with the help of some